Hey, it's Matt with the Chugach Mountain Institute up here at Thompson Pass again after a couple days of significant snowfall. Haven't been to this particular spot in about 5.5 months. It's the last place I skied at the end of last season with a super cool client from New York City, Matt K. What up, Matt? Hope you get some good skiing in this season, man. So I'm at about 3,700 feet, between 3,800 feet on an east aspect. I got about a 95 centimeter height of snow. Just dug snow pit with an extended column test, and got a ECTP 23 down near the ground, just a few centimeters from the ground on those basal facets. Above that, got like an ECT in 15 and 17. You can see where I kind of put those marks in the snow. Density changes in snowfall from probably the past 7 to 10 days. All right, so a couple other notes. This is a 24-degree slope here where I'm at. Chose to dig in because the terrain's getting bigger above me. So I felt like it warranted further investigation, despite the fact that I've not gotten any red flags today. Not to say there's not problems in the snowpack out there. We did just receive a significant snowfall, and it was pretty heavy, dense snow, which has definitely added a big load to the snowpack in terms of stress, but at the same time, it does seem like that dense, heavy Chugach snow is doing what it does. It makes it famous, and that's being relatively stable. All right, just a couple more visuals for you there. You can see that chunk right up here. This is the new snow from the past couple days, 12 to 14 inches. And there is the rest of the slab that failed on those basal facets. You can see them. Got some nice vertical growth, so some advanced faceting going on. 4,100 feet, still on an east aspect. Quite a bit different snowpack up here. Quite a bit deeper. It's 135 centimeter height of snow. The other thing I'm really curious about here is we did have one significant wind event earlier this season, and that made for a really hard packed layer. When I was up here last week, it was like knife hard. Dig through and saw through that layer this week, which was really difficult last week, and was able to get all the way down to the ground. So here, as opposed to where I dug that other pit, looks like we still got those basal facets. And then on top of those basal facets, though, we do have a thick wind-packed layer. And then on top of that, even more snow than you saw down about 400 feet lower in that last snow pit. So I've got an extended column test here again. That suspected failure layer on those basal facets is down beyond a meter, so it's kind of outside the parameters of a typical extended column test, but I'm still gonna do an ECT here and see what happens. Especially curious about those weak basal facets below that dense wind pack layer. All right, so I just did my ECT, and I got only an ECT in 11. You can see that ECT in 11 was where that snow has been removed from the ECT. So after that ECT in 11, I was tapping down there, basically right on top of that wind pack layer over the basal facets. Still did not get any reactivity on the basal facets. Right, so since I had done the work to already isolate this column in this big snow pit, I did just do another series of 30 taps on the other side of the column. I got an ECTN 17 this time, same layer. It did not propagate across even the roughly 60 centimeter column. And then again, no reactivity on the basal facets. All right, so I just did my final bit of assessment here at this pit, and that was prying behind the remaining bit at the column. Interestingly, up here, even prying behind the column with my shovel, it was hard to get it to release near the ground on the basal facets. There are basal facets here. They're much less pronounced than down low. And then if we think about maybe why that's happening, well, I think down below it was like a 95 centimeter height of snow, 135 centimeter height of snow up here. So, 40 centimeters is having an effect on the temperature gradient maybe. And that's, caused less faceting. So maybe a little bit more benign metamorphism going on up here. Another thing too is this spot where I'm at now more, but it is more wind exposed, and while the wind can load things up and stress the snowpack, create wind slabs, it also does work wonders for stability because small wind pack rounds bond pretty well and tend to be pretty strong, at least over time.